Figures 7.14 and 7.15, gradebook.java and gradebooktest.java. Now that we've introduced the concept of arrays in Java, we're going to go back and enhance our gradebook case study to be able to process an array of grades that's passed into a gradebook object as part of its initialization during constructor time. Now, first what I'd like to do here is take a look at the main application and run it so you can get a sense of what the program is going to do. In this example, we've got a main application where we first create an array of grades, and we've pre-coded a bunch of grade values into the array. And then we're going to create a gradebook variable called myGradeBook and initialize it with a new gradebook object. And you can see here we've modified the constructor from earlier examples so that it now receives a string representing the name of the course and an array of grades, in this case called grades array, that contains the grades that we'd like to process. We then tell the gradebook to display its message and then invoke its processGrades method, and as you'll see, this method is going to invoke a bunch of other methods in our class to produce the program's output. Now I'm going to go ahead and run this program first so we can see what the output looks like and get a sense of the capabilities in this example. So you can see here that as the program got up and running, it printed out "Welcome to the Gradebook for 4" and then the name of our course, CS101, Introduction to Java Programming. It listed out what the grades for each student were, so it listed students 1 through 10 and all of the grades in my array. It showed me the class average for all of the grades. It showed me both the lowest and the highest grade. And it gave me a grade distribution, or what you might refer to as a histogram or bar chart, that shows how many grades in each of the ranges you see here were actually specified in that array. We had no grades for the 0 through 59 values. We had 1 grade in the range 60 to 69, 2 in the range 70 to 79, 4 grades in the range 80 to 89, 2 in the range 90 to 99, and 1 perfect grade. So it was able to summarize all of that using various array processing techniques. So let's go back and take a look at the gradebook class now to see how we implemented this functionality. Now, previously in our gradebook class, we typically had one piece of data, the string that represented the course name. We now also have an integer one-dimensional array, which we're calling grades, and this variable is going to refer to the array that's passed into our gradebook object via main when we call the constructor of the gradebook. So the gradebook constructor receives the name of the course and a one-dimensional integer array, and you can see that we assign the name of the course to the course name instance variable, and we assign the array reference to the grades array variable, and rather than copying the array into this function, we're simply going to refer to, or into this object rather, we're simply going to refer to the array. Now, just like previously, we have some common methods such as the set and get course name method that enable us to change or obtain the value of the course name. We still have our old display message method that outputs as part of the message the result of get course name. And then we have this processGrades method that we called at the end of main, which is kind of going to control everything else that we do in this example. And we've got several other methods to look at: output grades to display the list of grades, get average to calculate the average of all the grades, get minimum and get maximum to figure out the lowest and highest grades, and output bar chart to display the grade distribution. So let's take a look at them in the order that we call them. Output grades first here. So I'll scroll down to our output grades method, and you can see here output grades defined at line 129. First we print out the grades are, and then we simply have a little for loop that's going to walk one element at a time through the array, and it's going to output a student number and a value of a grade for that student. Now, the reason we chose to use an a loop using the old counting style here is that we're using the counter control variable to help output the first column of information. Instead of outputting student numbers of 0 through 9 in the example, we wind up outputting student numbers of 1 through 10 because we're adding 1 to our counter variable. If we didn't need to know the student numbers, we could have simply used an enhanced for statement to walk our way through all the grades and output those grades. Going back up to our controlling function process grades here, the next thing we wanted to do was figure out the average of all the grades. And we're going to now jump down to the get average method, which you can see here at line 86. And we've started with a total variable because we have to add up all the grades to get the total. And this should be a familiar enhanced for loop for you because it's similar to one we did in a prior example. For every grade in the array grades, take that grade and add it to the total. So we eventually sum up all of the grades, and then we return the result of this calculation where we say take the integer total, cast it to type double so that we can get a floating point result, and then we divide that by the length of the grades array. So if the length of the array is 10, we'll divide the total by 10 to calculate the average. That gets returned as a double value back to the caller, where you may have recalled up above here that we output it with %.2f to say that we want 2 digits to the right of the decimal point. The next thing we do is find the minimum and maximum values in our array, and these two methods are quite similar. We start out by assuming that the lowest grade is the grade at element 0 of the array. And then what we're going to do is compare every grade in the array to that value, and if any particular value we encounter is smaller, we'll assign that value to the low grade variable and then return that at the end of the function. So here we're using an enhanced for statement once again, saying for every grade in the array grades, test the current grade that we're looking at to see if it's less than the low grade. If it is, take that grade and assign it to low grade. Otherwise, simply move on to the next iteration of the loop. By the time we finish this loop, low grade will contain the smallest value. And you can look at the get maximum method, and it works basically the same way. We make an initial assumption to help us with our simplifying of the process of determining the maximum grade. We assume that the element grade sub 0 contains the largest value this time, and we assign it to high grade. And then for every grade in the array grades, if the grade we're looking at right now is greater than high grade, then we will take that grade and assign it to high grade. After we've processed all of the values in the grades array, we will have the highest grade stored in the high grade variable, and we will return that back to the caller. Then finally, the last piece that we did back here in process grades was to call output bar chart to show the grade distribution. And for that, we go down to our output bar chart method. We begin by displaying the words grade distribution, and then we calculate the distribution using an array called frequency to store how many values in each range we received. So if you take a look here, you see that we are creating an 11 element array that has subscript values or index values from 0 through 10. And you may recall when we ran the program that the output showed you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different ranges of elements or ranges of values that we could be testing for. So we created an 11 element array for that purpose. All of those elements, by the way, are not initialized by us because they get free initialization of the default value for that type, which is int. So the type int has a default value of 0. Therefore, all 11 counter variables in this frequency array are already 0. We then walk through all of our grades, and for every individual grade, we divide it by 10. So if the value of the grade is 0 through 9, when I divide any number from 0 through 9 by 10 in integer arithmetic, I get 0 for this expression, which will result in me incrementing frequency sub 0. And if it were 10 through 19, the value of this expression would be 1, and I'll increment frequency sub 1, etc. I then have a for loop a nested for loop actually, that's going to produce the bar chart. It's going to walk through all of the elements of the array frequency one at a time. It's going to check to see if the value is 10 for the counter, and if it is, for that one we have special formatting that we'd like to do to output the value of 100 for our label. Otherwise, for all the other ones, we're going to output a label of the form %02D minus %02D, where the minus is a range indicator. And basically what we're saying is we want to output an integer in a field of 2 with leading zeros. So if it's the value 1, it would actually be output as 01, or the value 9 will be output as 09, etc. We then output the count times 10 and the count times 10 plus 9. So if the count is 0, I get 0 and 9. If the count is 1, I get 10 and 19. I get 20 and 29, etc. to output my ranges. And then for a given range, we have this nested for loop that says to output how many asterisks we need to represent that frequency. So we start counting from 0 as long as the stars counter is less than the frequency for that particular value, and we output 1 asterisk at a time. And then when we finish outputting the bar of asterisks, we output a new line to drop to the next line. So the nice thing about this is that we've now shown you a bunch of array processing capabilities, but more importantly, we've shown you that we can pass an array into an object as it's being initialized via the constructor, and then have the object process the elements of that array.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.